This video is about virtual circuits. When using virtual circuits, the network is a packet switch network, but it tries to emulate features of a circuit switch network. In the packet switch network, you do not allow that different paths are used for the communication of two end systems. All data units take the same path, and therefore the order of the data units is preserved. Each data unit has to contain address data to be able to decide about the forwarding. In reality, multi-protocol label switching, which is a frequently used technology within the networks of providers, is based on this principle. It is possible to differentiate how long virtual circuits are existing. Permanent virtual circuits exist for a long time and are usually set up by network administration. They are comparable to permanent circuits in circuit switch networks. Switched virtual circuits are set up on demand. So when a communication starts, there is at first an establishment phase to build the virtual circuit. A signalization protocol is needed for this purpose. As usual in a connection-oriented communication, there is also a usage phase and a decommissioning phase. The technology asynchronous transfer mode, which was used in backbone networks, supported both options. Advantages of virtual circuits are that pathfinding is only necessary at the beginning or not at all if permanent circuits are used. The sequence of data units is preserved. If you consider the origin of these two advantages, then you see that these are related to circuit switching. Since the basic network is packet switched, it is possible to dynamically find another path in the network in case of link or intermediate system failures. This is a packet switching based advantage. As a disadvantage, this method is more difficult to implement. On each intermediate system, it is necessary to administrate the existing virtual circuits. The connection establishment causes an initial delay in case of dynamically switched circuits. A tricky point is the question what kind of bitrate guarantees you can give. In a real circuit switch network, you can give hard guarantees on bit rates and delays. However, since the virtual circuits are based on a packet switch network, it is not so easy to give hard guarantees which hold in any situation. Often the guarantees are so-called statistical guarantees which hold like 99% of the time. But if users send an unusual high amount of data at the same time, then the performance may degrade. It is necessary to investigate the specific implementation to learn how this point is dealt with.